Hello everyone and welcome to the OneClass channel. My name is Donna Riel and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So now let's just get started on our set of questions for today's session. Okay. Question 1. Consider these reactions where M represents a generic metal. Using the information above, what is the enthalpy of the reaction? Okay, so here you'll notice that they give 4 different reactions, and they want us to find the enthalpy of a certain reaction below. So if you try to analyze everything that is given, these are pretty much all of the steps that need to take place in order for the last step to occur. So I'm just going to start by writing them all down, which is a good start when you need to do certain questions like this. So reaction 1 is 2M solid, which is a generic metal. So everything is already balanced, so we don't need to balance them. We have 6HCl makes 2MCl3 plus 3H2O, or H2. And the enthalpy of this reaction 1 is equal to negative 943 kilojoules. So the main goal of questions like this is to kind of tweak all of these different reactions so that we end up getting the reaction that we're looking for. I'll show in a minute after I'm done writing them all down. So just bear with me. I think this should be HCl aqueous. So if we tweak one of the reactions, like either multiplying it by 2 or like switching the order, we have to do the same thing for the enthalpy values. So in the end, we want to cancel out all the compounds that aren't in the final question. And we want all of the coefficients to match as well with our desired reaction. Okay, so I'm on the last reaction. So these kinds of questions can be confusing at first, but the more you do them, the more that you'll recognize that once you tweak an equation, ideally you don't need to tweak it again, and usually it all just kind of works out. So I'll put our desired equation at the bottom just to help us figure out how we want to tweak all of the other reactions. So ideally, we want 2m solid plus 3Cl2 gas makes 2MCl3 solid. Okay, so at some point, we want our 2m solid to stay the same because it is still in our desired equation. So I know I don't want to tweak the first equation at all, but I want to cancel out this HCl aqueous, which is on our reactant side. So I need to find an equation that has HCl aqueous on the product side to cancel it out. And I know I need to multiply that equation by 6. So if we look at all of our options, we'll see that equation 2 has HCl aqueous on its product side. So all I need to do is multiply equation 2 by 6, just so that the 6 HCl's will cancel out. And I also know to multiply my delta H2 value by 6 as well. Okay, so continuing on, we know that we want to have our Cl2 gas in our reactant side as well, because it is in our desired equation. So we know that we don't need to switch this over to the product side since it is already on our reactant side. All we need to do is multiply this whole reaction by 3. And we do the same thing to our delta H3 value. And then if we look at our last equation, you'll see that MCl3 solid is in our reactant side, but in the desired equation, there are 2 moles of MCl3 solid on our product side. So not only do we have to multiply the last equation by 2, but we're also going to multiply it by a negative. So by multiplying these reactions with a negative value, this pretty much switches the products and the reactants so that the products become the reactants and the reactants become the products. And we also need to multiply our delta H4 value by -2 as well. Okay, so now I'm going to rewrite the equations to get, I'll just call them like the tweaked equations at the bottom here. So bear with me while I quickly write everything down. So it's a bit like redundant to write down all of the different reactions, but it helps us in the end just so that we can verify that we did all of the steps correctly. So again, we didn't have to change our first reaction at all. But for the tweaked second reaction, we had to multiply by 6. So now we have 6 HCl makes 6 HCl aqueous. And our new delta H2 value was multiplied by 6 as well. I'll do all the math later. But for now, I'll just show what the reactions look like. For 3, we just multiplied by 3. And lastly, we switched our reactants and our products, and we multiplied it by 2 as well. So now it becomes 2MCl3 aqueous makes 2MCl3 solid. Okay, so this step was just to verify that we did everything correctly, and if we cancel out all of the compounds that are in the reactants and the products, then we should end up with our desired equation. So for example, 6HCl aqueous is on the reactant side and the product, so I'm going to cancel it out. And 2MCl3 aqueous is in the products and the reactants here. 3H2O gas is in the products and the reactants on this equation. And then 6HCl gas is here and here. So all of those are now canceled out. And you'll notice that we have left over our desired equation. So the 2M solid plus 3Cl2 gas makes 2MCl3 solid. So now we need to find the delta H of the reaction. So this is the sum of all of the side reactions that occurred, and we also need to take into account all the multiplication steps that we performed as well. So I'm just going to show what it would be equal to. So it's 943 kilojoules from reaction 1 plus 6 times negative 74.8 kilojoules. So that's from reaction 2 plus 3 times negative 1845 kilojoules plus or minus, since it's a negative 2, we're going to minus 2 times negative 155 kilojoules. And I can just quickly fit it at the bottom here. If you were to calculate what this is equal to, you should end up with negative 6,616.8 kilojoules. So this is the enthalpy of the reaction. Okay, so again, it's just the multi-step answer that requires a lot of steps, but ultimately it's pretty easy to figure out how to do questions like this. Let's see what the junior tutor said. They have equation 1, equation 2, equation 3, and then equation 4. But reversing equation 4 will reverse the sign of delta H. So they also showed how when you switch your products and your reactants, then that also multiplies your enthalpy value by negative. Okay, so multiplying with the necessary coefficients and adding equations 1, 2, 3, and 5, we get the following. So they showed how they didn't tweak equation 1. They showed equation 2 was multiplied by 6, equation 3 multiplied by 3, and then equation 4 is multiplied by 2. And then they calculated enthalpy to be negative 6,616.8 kilojoules. Yep, so this solution is correct. Great breakdown of steps.